Hello and welcome to today's lesson on the basic area formulas. Today's lesson is going to focus on the area of rectangles, parallelograms, triangles, and trapezoids. Most of these formulas are going to be a review, but there are some new formulas that we will take a look at as alternate formulas for a triangle. Before we go on to the lesson though, I just want to give a little highlight of the types of formulas you'll be seeing in this unit. I will give all these plus maybe some more on the quiz at the end of the unit. Today's lesson though is focusing on these three formulas: the rectangle, the triangle, and a trapezoid. So no need to copy those down for now. First, let's look at the area of rectangles and parallelograms. This is the most basic area formula because it's just base times height. Now I want you to note something. Whatever you're multiplying has to be perpendicular. So the base and the height are always perpendicular. They're always perpendicular. So when you have a rectangle, so let me draw a rectangle, every side is perpendicular to an adjacent side. So the base times the height, you just have to multiply the sides. Done. Got the area. So for number one, for instance, we have a rectangle because we have four equal angles, so it's a rectangle. So you multiply the base, which is the 23.1 feet, times the height, which is 19.4 feet. Now I do want you to include the feet, the units, whatever the units are going to be, in the formula substitution, because it's going to show that we end up getting feet squared, because we're going to multiply the numbers, and if we multiply 23.1 and 19.4, you get 448.14, but you also have to multiply the feet, so feet times feet is feet squared. So the area of this rectangle is 448.14 feet squared. And in fact, every area problem that you have will be whatever the units are squared. Now let's look on to number two. So now we have parallelograms, because we have two pairs of parallel sides. Now in a parallelogram, the sides aren't necessarily perpendicular, so you have to use the base, which is one side, and then a length that is perpendicular to that side. Now note, this is an important property to remember about parallelograms, is that opposite sides are equal. So the base could be labeled above or below. Doesn't really matter. But the height will always be the same no matter where you are. So if you're right here, that's also a height, and it's going to be the same length. Okay, but you only need to have one of them. Okay, now let's look at an example. So number two, we have a parallelogram. Notice I have the base and I have the height. Those are two perpendicular lengths. Even though the perpendicular symbol is down here, I know it's going to also be up here because the lines are parallel, and that would create part of a little rectangle. Okay. So the area is the base, which is 10 centimeters, times the height, which is 6 centimeters. Okay. And again, we multiply the numbers, we get 60. Multiply the centimeters, you get centimeters squared. So the area of this parallelogram is 60 centimeters squared. Let's look at example 3. Now number 3, notice I have a base of 12, and I have the other side is 5, and part of the other base is 9. I don't have the height though. I need the height in order to find the area. Now to find the height, we're going to be using this little triangle over here on the left. Notice because it's a 90-degree angle with the side, it's also going to be a right triangle. And I need to know the other two sides of that triangle to help find h. Because opposite sides are equal in a parallelogram, this entire base down here has to be 12, so this must be 3 meters, because 12 minus 9 is 3. also opposite sides are equal, so this length over here is going to be 5 meters. Now I can use the Pythagorean theorem to solve for that height. The height squared plus 3 squared is equal to 5 squared. And the 5 is by itself because it's across from that right angle. Okay, and then you can go ahead and continue solving that. H squared plus 9 is equal to 25. H squared, subtract the 9, gives you 16. So H is equal to 4. Technically plus or minus 4, but we're dealing with length, so we're just dealing with 4. So the height is 4 meters. Now I have the base, which is 12, and the height, which is 4. So now I can find the area of that parallelogram. So it's going to be 12 meters, which is the base, times 4 meters, which is the height. That gives me 48 meters squared. Pause the video now and write down anything you need to before moving on to the next area. Now before we move on, I just want to point out one thing. This is called meters squared, or it could be called square meters. They mean exactly the same thing, so depending if it's written down in words, you may see it one way or the other. So you can say 48 meters squared, or 48 square meters. Now let's look at the area of a triangle. The area of a triangle is base times height divided by 2. Continue to note that the base and the height must still be perpendicular. They're always perpendicular. Oops, are always perpendicular. And there are 3 basic types of triangles we're going to look at. One's the acute, one's a right, and one's an obtuse triangle. In an acute triangle, which is mostly what you usually see, you have a base, and your height is drawn perpendicular to that base. Let me draw a little bit better B. There you go. So the height and base are still perpendicular, so it's going to be base times height divided by 2. If you had a right triangle, then 2 sides are perpendicular, and those 2 sides might be the base and height. If you have an obtuse triangle, then if you have that side being the base, you can't just draw perpendicular rights to where that base is. You kind of have to extend that bottom side out to find out the height, because the height is always the distance perpendicular to the base. But in an obtuse triangle, you have to extend the sides to find the height. So for these triangle ones, you have to make sure you have the 2 perpendicular sides before you can find the area. And notice number 4, I have that. 9 and 16 are both the sides that are perpendicular, so we have the base and height. So the area is going to be 16, which is the base, times 9, which is the height, divided by 2. Multiply the tops. 16 times 9 is 144, divided by 2 is equal to 72. Now area is always units squared, so I'm going to leave my answer as 72 units squared. We don't have a specific centimeters or feet or inches or yards, whatever the case may be. So we have to write just U squared when there's no units given. Alright, let's look at number 5. We're going to ask ourselves, do we have the base and the height, the 2 perpendicular segments? Well, I have the height. The height's 12, because that's the part that's perpendicular to a side. But I only have part of the base. I need to have the entire base. So I'm going to solve for that little part, which will then allow me to find the entire length of the base. So again, I have a right triangle. Pythagorean theorem is going to be a big part of today's lesson, especially because we're dealing with perpendicular sides with area. Okay. So x squared plus 12 squared equals 13 squared. Again, the 13 is by itself because it's across from the right angle. Okay, go ahead and pause the video now and continue solving this problem, see if you can get the answer. Okay, so hopefully you've gotten the answer. That little base part is going to be 5 feet. So that means the entire base is going to be 15 feet. So the entire base is going to be 15 feet. So now I can plug into the area formula. Base, which is 15 feet, times the height, which is 12 feet, divided by 2. 15 times 12 is 180. So we have 180, and feet times feet is feet squared, divided by 2. So you should have gotten 90 feet squared. Alright, now let's look at number 6. Pause the video now, see if you can try this problem, and then we'll work on it together. Alright, so you're missing the base. You have the height, missing the base, so you have to solve for it. You can't just multiply the 8 and the 10, because those aren't perpendicular lengths. Can't do that. So, we're going to use Pythagorean theorem again. Now, 10 is crossed in the right angle, so you should have set up the equation. X squared plus 8 squared is equal to 10 squared. And solving that, we end up getting x equals 6. Okay, so that length, that base is 6 inches long. Now I have the base and the height, so I can plug into my triangle area formula. Base, which is 6 inches, times the height, which is 8 inches, divided by 2. Which gives you 48 inches squared divided by 2, which is 24 square inches. Pause the video now, write down anything you need to before moving on. Okay, now let's look at trapezoid area formula. This one's a little more complicated, but again, I'll give this formula to you so you don't have to memorize it. What you're going to do, now before I write this formula, I want to draw a picture of a trapezoid. Trapezoid, remember, is a quadrilateral that has only one pair of parallel sides. Now, technically, you can create a parallelogram with a trapezoid, but I won't show you that just yet. I'll show that once we get the formula down. You need to know the height. Notice there were no perpendicular sides given, so I drew in this height that's perpendicular. But the bases are going to be different lengths. So we actually have two bases that are different lengths, and we're going to use those two bases in the area of a trapezoid. And what we're going to do is we're going to add those two bases to get a length, and we're going to multiply it by the height, then we're going to divide by 2. Now that's kind of like an area formula that's just like the triangle formula, but it's also kind of like the parallelogram formula. Now I just want to show you something, okay, just so you can kind of understand where this formula is coming from. If I were to take this trapezoid, flip it upside down and match it on top of what I have, I would get something like this, where base 1's down here and base 2 is up here. Notice that creates a parallelogram, and the area of a parallelogram is base times height. So the base is base 1 plus base 2 times the height, which is h. However, that's twice the original figure, so you have to divide by 2. So really, this is a parallelogram just divided by 2. Okay, so just a little explanation as to why that formula is written that way. But let me get rid of this because that's not necessary for solving these problems. You just have to know how to apply the formula. So I need to know both bases and the height. Remember, the height needs to be perpendicular to the bases. And in trapezoids, it'll be perpendicular to both. So in number 7, I have all those pieces of information. The first base is 6 centimeters, second base is 11 centimeters, and the height is 4. And just a little side note, it doesn't really matter which one is base 1, which one is base 2. As long as you use those two bases and add them together, you get the same amount. Okay, so the area is going to be 6 centimeters plus 11 centimeters, that's base 1 plus base 2, times 4 centimeters divided by 2. Now I see 3 centimeters there, but we're not going to have centimeters cubed because the 6 and the 11 centimeters combined to become 17 centimeters. It's kind of like your combined like terms. Centimeters are like terms. So 17 centimeters times 4 centimeters divided by 2. And that's where we're going to get our units squared from. 17 times 4 gives you 68 centimeters squared divided by 2. So the area is going to be 34 square centimeters. Okay. That is going to be the area of that trapezoid. Okay, pause the video now, see if you can figure out number 8. Make sure you have all bases and heights that you need. Okay, let's work through number 8 together to see if you were right. I see one base. Now that length is 4.8 plus 8.2, which adds up to 13. So that base is actually 13 units long and a base of 5. But I don't have a height. So hopefully you realize you need to use Pythagorean theorem because that's a right triangle. And it's going to be h squared plus 4.8 squared is equal to 8 squared. Now you have decimals here, but it might turn out to be a nice number. Let's see. 4.8 squared, type that in your calculator, you end up getting 23.04. Subtract that from that 64. We get h squared is equal to 40.96. Take the square root of both sides. You end up getting h is 6.4. Okay, that's a nice number. No rounding needed. 6.4. Now I have the base and the second base and the height. I can plug into the area formula. So it's going to be base 1, which is that 13, plus base 2, which is 5, times the height, which is 6.4, divided by 2. So essentially I have 18 times 6.4 divided by 2. When all is said and done, we end up getting 57.6 after we divide by 2. So it's going to be 57.6 units squared. No units were in the diagram, so we have to include the units squared. Pause the video now, write down anything you need to before moving on. Okay, and we're going to look at alternate area formulas. I'll give you these formulas. Okay. You can actually find the area of a triangle using trigonometry or square roots. Okay. Using trig, okay, it turns out that if you have two sides in the included angle, notice this is a side angle side triangle, you can actually find the area of the triangle without having to deal with any kind of perpendicular sides. Because the side of an angle changes and it actually accounts for the perpendicular side in some way. That's magical, but we don't have to worry about that. What this is saying is you're going to take half of the sides multiplied together times the sine of the angle. Doesn't matter which one you label as A and B. Okay, I'll label 9 as A and 3 as B. So the area is going to be 1/2 the 9. I'm going to write the meters times 3 meters times sine of the angle, which is 93 degrees. Now you can just go ahead and type that entire thing in. Make sure, though, before you do this, that you are in degree mode. Okay, so plug that into your calculator, see what that gives you once you're in degree mode. You'll see that your calculator tells you that it is approximately 13.48149872 ... because it keeps going on and on and on. I didn't specify how to round for these, but let's round these to the nearest hundredth. So it's 13.48 meters squared, because we're dealing with meters as units. Okay, and that's just it. Take the sine, well, you just take half of multiplying the sides together times the sine of the angle. Now it works for a side angle, side triangle. Now for a side triangle, if you know all three sides, you're going to use something called Heron's formula. And it uses something called a semi-perimeter. Semi means half. The perimeter means the perimeter. Just the outside sides lengths added together. Half the perimeter. So, in order to use this formula, notice that semi-perimeter occurs in the formula in each substitution, each factor. And we're subtracting off the side lengths from the semi-perimeter for 3 of those factors. So we have to calculate the semi-perimeter, and the semi-perimeter is half the perimeter. The perimeter is found by taking A plus B plus C, so we're going to divide it by 2. So for the example given below, the semi-perimeter is going to be 5 plus 7 plus 10 divided by 2. Just add up all 3 sides and divide by 2. That'll give you the semi-perimeter, which is half of the perimeter. 5 plus 7 plus 10 is 22. So that means the semi-perimeter must be 11 yards. Okay, now if I plug this into the formula, notice I'm going to have yards times yards times yards times yards. So I will end up eventually having yards to the 4th. And we take the square root of yards to the 4th, that gives you yards squared. So let's just not worry about the yards out in the formula substitution for this problem. Okay. The area, notice what you're doing is you have 4 things. One is just a semi-perimeter, and the other 3 things are the side lengths taken away from the semi-perimeter. But they're all underneath the square root. Okay, so I'm going to go into this little black area because I want to make sure I have enough room to do this. So the semi-perimeter is 11, so I start off with 11. Then I have to take 11 and subtract off each side. So 11 minus 5, 11 minus 7, and 11 minus 10. Now, there's a lot of parentheses there, so what I would suggest you do is calculate each number inside the parentheses first. So we have 11, we have 6, we have 4, and we have 1. Now let's multiply all 4 of those numbers together. If we multiply the 11, the 6, the 4, and the 1, we get 264. Now that's something we can take the square root of. So A, the area, is going to be approximately 16.24807,681. Just need to round to the nearest hundredth again. 16.25 yards squared. Alright, pause the video now and write down anything you need to before moving on to some additional problems that you'll see in your assignments. Okay, so you saw all the formulas for today's lesson, the rectangle, parallelogram, triangle, and trapezoid, and some alternate triangle formulas. Now you're going to see some problems on the back side of your assignment that look like this, where I give you a figure, maybe a rectangle, maybe a triangle, maybe a trapezoid. Doesn't really matter because we have a formula for each of those things. And I'm going to give you the lengths in terms of x. So let's say I have this length is x plus 4, and this length is x minus 1. And I'm going to give you that the area is a certain amount. Okay, in this case, I'm going to be given that the area is 50. Let's say centimeters squared. Okay. Area is 50 centimeters squared. Well, I know a formula for the rectangle is area is base times height. Yeah, I'm just going to plug in everything that I know and solve for x. I know the area is 50, so it's going to be plugged in for a. I know the base is x plus 4. And I know the height is x minus 1. So I just have to solve that equation now for x to find out what the value of x is going to be. And that's what I want you to do in your assignment, is find that value of x that makes that area equal to 50. So I have to multiply this out, the x plus 4 and the x minus 1. I get x squared, and feel free, by the way, to do Punnett square if you want to, because I know some of you feel more comfortable with the Punnett square. X squared minus x plus 4x minus 4. Combine like terms. The negative x and the 4x makes a positive 3x. Alright, and then I'm going to subtract off the 50 from both sides. I get 0 is equal to x squared plus 3x minus 54. So we have to factor this because we have a quadratic equation with an x squared and an x term, so we can't just take the square root of both sides, we have to factor it. You have to find the two numbers that multiply to that negative 54 that add to that 3x. Think about that for a second. Okay, hopefully you got it was positive 9 and negative 6. Solving this further, we can use the zero product property to set each factor equal to 0 to solve for the values of x. So we get x equals negative 9 and x equals 6. Now, as is always has been with diagrams that have pictures in the problem, you have to make sure you have positive lengths for those values of x. Now notice if I plug in negative 9, well, that's clearly going to give me a negative length right here for the x minus 1, because that gives you negative 10. So we can automatically eliminate that solution to the equation. Plug in 6. Well, that would make this 5. This would make this 10. 5 times 10 is 50. That works. So therefore, the solution to this problem is x equals 6. So all I did for this type of problem, when you see it in your assignment, you're going to be given this information, the area and then the size in terms of x, and you just got to look at your notes to find out which formula to use. If it's a triangle, you're going to use base times height over 2. If it is a trapezoid, you're going to use base 1 plus base 2 times the height divided by 2. And if it's a rectangular parallelogram, you're going to use areas base times height. And substitute everything you know and solve the equation for x. You may have to factor using a quadratic equation to factor, or you may just be able to solve for x as a regular linear equation. Pause the video, jot down anything you want to before going on to the next slide, which will sum up the lesson. Okay, so in today's lesson, we were able to see the basic area formula, and those formulas were area is equal to base times height. That worked for a rectangle or a parallelogram. And we also saw the area formula for a triangle, base times height divided by 2. We saw the area formula for a trapezoid. You have to add the bases, multiply by the height, divide by 2. That's going to be the trapezoid. And we also saw some additional area formulas for triangles. Area is equal to 1/2 a times b times sine of theta That's in a diagram where you have some angle. There's two sides next to it. Side angle, side. And you also saw Heron's formula, which is the square root of the semiperimeter times the semiperimeter minus a side length times the semiperimeter minus another side length, b, times the semiperimeter minus a third side length. Notice those are s's. And the s is found by taking a plus b plus c and dividing it by 2. That happens when you have a triangle like this. We have all three sides. Okay, another important thing to remember from this lesson is that in order to use the area formulas, you have to have lengths multiplied together. The base and the height are multiplied. They're perpendicular. Okay, they have to be perpendicular to each other. The base and the height in the triangle are perpendicular. The two bases added together and the height are perpendicular. But the special triangles, alternate formulas for triangles, that's just a formula. Plug it in, given the side angle side or side side side. Thank you for watching. If you don't have your assignment now, raise your hand and your substitute will give it to you. I'll be back tomorrow. Thank you.